Hi, how are you? I'm happy to be with you today. This is the first time for me to make a video on YouTube for math. So it gives me the greatest pleasure to make this video for semesters. Okay, let's start our lesson for today. Our lesson today is about the exponential function in general, the real meaning of the exponential function. Then, by the end of this video, you are going to identify the real meaning of the exponential function and also the meaning or the real life applications of the exponential function. Either we have doubling, quadrupling, or tripling functions. And also, you are going to identify the increasing rate, which is called the growth function, and the decreasing rate, which is called the decay function. So let's start also for today with the first slideshow. Uh, in this presentation, I'm going to make a new meaning for our exponential function. Let's start with this. Okay, the exponential function life applications, and these are the objectives of the exponential function. Okay, then by the end of the session, as I told you, the real meaning of the exponential function and real life applications with doubling, tripling, or quadrupling, increasing rate or decreasing rate. So I'm going to start with you with a simple example to find out the meaning of the exponential function. Zoologists come to the meta to count the number of cows in the meta, and that they found that the total number of cows in the countryside of the meta is about 1,000, and this number is doubling each year. Then we want to find out a technique we can use to find the number of cows after 4 years or 5 years according to the required or the inquiry in the given example. So what I must do, if you imagine that we have 1,000 cows, and after 1 year, if this number is doubling after 1 year, how many cows do you have? Okay, 1,000 in doubling means multiply by 2. 1,000 times 2, which is equal to 4,000. And after the second year, you will get 4,000 times 2, which is equal to 2,000 times 2, which is equal to 4,000. And after the third year, you will get 4,000 times 2, which is equal to 8,000. Let's see this technique to count or to try to find out a formula we can use to find the total number at any interval time. So the initial after 1 year, after 2 years, after 3 years, and then at the time after which we start to count is 1,000. This is the initial amount of cows. And that after 1 year, 2,000, after 2 years, 2,000 times 2, which is 4,000, 4,000 times 2, which is 8,000, 8,000 times 2, 16, 32, 64, 120, 4, and so on. Okay, let's complete our discussion. Then you will, if you looked intently at these numbers, you will find out that these numbers are multiples of 1,000. And then we can rewrite these numbers again in the form 1 times 1,000, 2 times 1,000, 4 times 1,000, 8 times 1,000, 16 times 1,000, 32, and so on. And then if you looked intently or carefully at these numbers, the relation between 2 and 1, and 4 and 2, and 8 and 3, and 16 and 4, 32 and 5. Actually, you will find out that these numbers, 2, 4, 8, 16, 32, are the base 2 raised to the number of years. Okay, multiplied by 1,000. This is the amount, total amount in general. Okay, for example, 4 is 2 to the power 2. 32 is 2 to the power 5. 8 is 2 to the power 3. 16 is 2 to the power 4. Okay, then we can find out a formula to count the total number after the number of years. What about after 8 years? It will be 2 to the power 8 times 1,000. Here we have 2 to the power 5 times 1,000. Let's complete our discussion. 2 to the power 0 times 1,000, 2 to the power 1 times 1,000, 2 to the power 2 times, and so on. Then after 8 years, it will be 2 to the power 8 times 1,000, okay? Then we can deduce a general formula to this to sum up all these discussions about this part, and we can say in general that the f of x equals 1,000 times 2 to the power x, where x denotes the interval or time interval or the number of years, as you like. Okay. Then we deduce now that the general form of the exponential function of x equals b to the power x, where the initial amount is 1. Okay, in case of initial amount is 1. A checking point. Of how more is this 150 rabbits, he found that the number of rabbits is tripled each year. Find the total number of rabbits after 4 years. Then here we have in this example that the total number or the initial number of rabbits is 150. And this number is tripled, not doubled here. In this case, is tripled. Then what will be the formula we will use here? Yes, we can say that, yes, 150 is the initial times 3, as he told us this number is tripled each year, to the power x, to the power x. But here the interval time or time interval here is after 4 years, then to the power 4. Okay. Let's move into another part of our discussion for today, and I'm going to talk to you about the rate of growth or decay. In this part, I'm going to give you an introductory example to show how to reach or to deduce the law of the rate of growth or the function of growth or the function of decay in general. As you know that A equals B times 1 plus R all to the power T. We want to find out how did you get this formula. Then let's see with me this example. Suppose that the amount of money is 1,000. This amount of money is increasing by 10% each month. Then after 1 year, after 1 month, after 1 month, how much money will you get? Then the initial amount at time 0 is 1,000. After this time, you will get 10% plus 1,000. But 10% of what? 10% of 1,000 plus 1,000. And 10% of 1,000, which is 100 plus 1,000, which will be 1,100. Let's see how did I get the answer. I'm going to make a relation between time and total amount, and I'm going to give a name for the total amount of money, which will be A. Here we have at 0 time, at the initial value is 1,000. At no time, at the time after which we start to count the number of months, okay, will be 1,000. After that, after the end of the first month, then you will get 1,000 plus 10% of the 1,000. You will get, if you factored out 1,000 here, then you will get 1,000 times between 2 parentheses 1 plus 10%. Okay, and you can repeat this equation all the time. This will be the initial amount in the second month, and then I'm going to find out 10% of this. If I try to show this in other ways, and I'm going to, okay, I'm going to, let's complete our discussion. Yes, in the second, after the end of the second month, then you will get 10% of this number plus this number, and you will factor out 1,000 times 1 plus 10%, the initial value, plus 10% of this number in the after the end of the second month. And we can factor out 1,000 times 1 plus 10% out like this, and you will get, after that, you will get this number. And each time you will repeat this operation, and then at the end, you will get 1,000 times 1 plus 10% all to the power T after T years, okay? Then we identified the technique we can use in general to find the growth function if you have an amount of money and this amount of money is increasing monthly. Okay, for example, I'm going to give you an example. Ahmed bought a car, bought a house, and this house is increasing by the rate 5% each year. Find the total price of the house after 10 years. Then you can find this formula. Ahmed bought a house for 100,000 pounds, and then you can, if you plug in 100,000 and 1 plus 5%, which is equal to 5 over 100, you must put it or convert it into a decimal fraction, all to the power 10 years, and then you can find the actual price of the house. Let's complete our discussion and move on to another part, increasing rate exponential growth. And let's make a comparison between the two examples. In case of increasing rate or exponential growth, A equals B, P times 1 plus R all to the power T. And this example, I'm going to give you a real life example, and because of this example, you are sitting in your house. For this example, says that at the beginning of the crisis, the Chinese mathematicians found that the initial number of infected people of COVID-19, which is well known by coronavirus, is 1,250 persons, and that this number increases by the rate 5% weekly, finds the total number of infected people after 7 weeks. Then here, the Chinese mathematician found that the total number of was the initial amount of number, was the initial number of infected people of COVID-19 is 1,250 persons. This is at the beginning of the crisis. And that this is represents, if I'm going to plug these values here, P, which is the initial value, will be 1,250, and the rate, the increasing rate here, this is increasing rate, as he told us, increases by then 5%, which will be 5 over 100, which is equal to 0.05, all to the power T. He want to find this number after 7 weeks, then T here is 7. As you see, this is our solution, okay? P, R, T, and the formula. Let's move on to the other example here. As you see in this example, decreasing rate or exponential decay. By the end of, this is in the opposite side, we have a contrast here between the two examples. This is for growth function and this is for the decay function. Here you will see that by the end of the crisis and after taking precautions, the Chinese mathematicians found that the number of infected people of COVID-19, which is well known by coronavirus, is 8,000 persons, and that this number decreases by 0.7% weekly, finds a total number of infected people after 6 weeks. Then if I'm going to compare between the numbers here and between the formula and plug in these values into this formula, then the initial value here is 8,000 persons infected people, that the number of infected people is 8,000 by the end of the crisis. And also the rate of decreasing, or the decreasing rate, is 7%, which is equal to 0.07. And he wants to find the total number of infected people after 6 weeks. Then this rate, make sure that this rate is in weekly, okay? And this is also in weeks. Okay, then you can plug in these values directly and you can get the answer, okay? Then you have enable, I know that you don't have enables. Okay, let's move on to another part of our lesson for today, and this is the checkpoint example. The number of population in a small city in Arab Republic of Egypt reached 1.9 million people with average increase 3% annually. Estimate the number of population after 5 years. Then in this example, you have a population, the initial value of the number here, initial number here is 1.9, 1,900,000 persons or people, and this number is increasing by 3% annually, and you want to find the number after 5 years. You can solve this easily. It is easy to solve it. Okay, let's move on to another example for today. Here, I'm going to solve this example with you. The value of a car, this is a challenge. The value of a car is $21,500. It loses 12% of its value every year. Number A, write a function. Make sure that it loses 12%. Write a function that represents the value Y in dollars of the car. In this example, I'm going to talk to you about how to solve this example. Then, do we have here increasing or decreasing rate, decay or growth? Yes, we have decay. Why? As in this example, we have a loss. We have a loss. It loses. Okay, it loses 12%. Then I'm going to use the other formula, which is A equals B times 1 minus r all to the power t. Okay, and the initial value of this car is 21,500, and let's complete our discussion. Then I'm going to use this to represent the answer. Okay, A is the final amount of, or the final amount of money after T years, okay? And P is the initial value here, which is 21,500. 1 minus R here is 12 over 100, which is equal to 0.12. And after T years, he won't find the general formula for the decreasing function or the decay function. Number P, then this is the answer, okay? Number V, find the value of the car after 5 years. If you plug in 5 here instead of T, then you will get the price of the car after 5 years, okay? The price of the car after 5 years. C, find the approximate monthly percent decrease in value. Pay attention, look intently and carefully for this part of the problem. He wants to find the approximate monthly percent decrease. What was the approximate monthly percent? We have here the approximate yearly percent decrease, which is 12%. It loses 12% every year, not every month. I want to find the decay percent monthly. Okay, how to find this? I'm going to make use of this formula again, and I'm going to rewrite T, which is in years here, as in the form 1 over 12 times 12 T, and where T is in months. Okay, like this. I'm going to use the fact that T equals 1 over 12 times 12T, and then in this time I didn't change this amount. Okay, then we have, if I'm going to plug this here instead of T here, then I'm going to get or obtain A equals 21,500 times 0.88 all to the power 1 over 12 times 12T. Then we didn't change the formula. Okay, and then I'm going to disjoin the two powers here and put this inside the bracket and the other outside the bracket as this. Okay, I'm going to put 1 over 12 here. This is the same as this, but I'm going to take the 12th root for 0.88 using the calculator and to the power 12t as this, okay? And the decay here is the monthly decay. But 0.99, which is equal 1 minus r, and using the fact that 1 minus r equals 0.99, then we get r, which is equal to 1 minus 0.99, which is equal to 0.01, which is equal to 1%, and this is the percent decay monthly, okay, or per month. I'm going to talk to you about something. So I'm finished now. The next time, inshallah, I'm going to talk to you about the compound rate annually and the compound rate continuously. And I'm finished now. Until the next time, see you. Bye-bye.